Welcome to Sizewell B. This unique experience will help us explore how we safely and securely generate low-carbon electricity here at Sizewell B. Helping Britain to achieve net zero is at the heart of everything we do. Sizewell B is the UK's only pressurised water reactor, commonly referred to as a PWR. EDF is the only operator of nuclear power stations in the UK, Sizewell B being the newest power station in the fleet. We generate 1,200 megawatts of electricity using a low-carbon technology. Sizewell B first generated electricity on the 14th of February in 1995 and is continued as a baseload station, providing 3% of the UK's electricity. That's enough electricity to power all of the homes in Suffolk, Norfolk and Essex. Nuclear safety is our overriding priority, and it is a culture that is firmly embedded throughout our organisation, and it governs everything we do here at Sizewell B. A nuclear site licence is granted to us by the government. This is the authority to operate the power station and mandates that we must follow a very strict and precise set of regulations and guidelines. We have a number of governing bodies: the Office for Nuclear Regulation, the Health and Safety Executive and the Environment Agency. They regulate and continuously monitor everything that we do, to ensure not only the safety of the power station and our staff, but also the local community and environment around us. We also have our own team of internal regulators, inspectors and safety advisors who monitor and advise us. They look at everything we do. Zero harm is our key focus, and we openly report and monitor any events, accidents or near misses, no matter how small they might be. Our safety record is displayed for everyone to see as they enter the power station, alongside our generation output figures. Sizewell B is an amazing feat of engineering with a highly skilled task force of around 800 local employees, all living within 25 miles of Sizewell B itself. The career opportunities here are abundant and diverse. As well as engineers and scientists, there are accountants, occupational health advisors, scaffolders, chefs, communication specialists, experts in human resources, design and quality management, and lots more. The safety and well-being of our people is important to us. We have a dedicated safety centre providing safety advice and experience from other power stations around the world, and an occupational health department looking after the well-being of our staff. We have a skilled maintenance team and an industry-leading apprenticeship scheme. Our apprenticeship is 4 years long, and the first 2 years are spent at college in Somerset, alongside other apprentices from across the business. The apprenticeship scheme covers general engineering principles, then specialises in either electrical, mechanical or control and instrumentation engineering. The last 2 years are spent on site at the power station, putting into practice the classroom learning, working alongside our qualified and experienced team. We also offer degree-level apprenticeship schemes and a graduate entry programme, as well as work experience. Safe, reliable generation is achieved by having a robust maintenance schedule of testing and monitoring, ensuring every part of the power station is performing safely and as designed. Our stores area holds everything from protective gloves to neutron absorbers, stocking over 30,000 different items. It is essential that we have the right equipment available when we need it. A PWR is designed to operate continuously for a full 18-month cycle. A refuelling outage is where we stop generating electricity, refuel the reactor and do all the maintenance that we can't do whilst we're at power. This happens every 18 months, where a vast number of tasks are planned to maintain the power station. Each task has to be planned and executed in the safest and most efficient way possible. To achieve this, we employ additional local people as well as specialists from within the UK and across the world. Sizewell B's iconic dome houses our reactor building. The dome is 25% bigger than the dome of St Paul's Cathedral in London. The reactor core itself, though, is only 4 metres tall and 3 metres wide. The dome also houses 4 steam generators and a pressuriser. The building wall is made of 1.3 metre thick reinforced concrete containing 8,000 tonnes of steel reinforcing bar. The white dome that we can see is a smaller outer wall with cladding. The building is seismically qualified and tested to withstand aircraft impact. Sizewell B is a pressurised water reactor. We heat the water to create steam, which turns our turbine, and we create electricity. The water needs to reach a very high temperature, approximately 325 degrees C, to create exactly the right amount of steam at the right pressure to turn our turbines. To do this, we place the water in our primary circuit under a huge amount of pressure, 155 bar. This increases the boiling point of water, enabling us to reach the high water temperatures required. This produces enough steam to turn both of our turbines and produces 3% of the UK's electricity, helping Britain to achieve net zero. Unlike fossil fuel power stations, we use science to heat our water. Our fuel is uranium. Uranium occurs naturally and is mined, enriched and made into pellets, specifically designed to be used as fuel in a nuclear reactor. These pellets are arranged to form a fuel assembly. There are 193 fuel assemblies in the reactor, each containing roughly 97,000 pellets. Each tiny pellet has the same energy as 800 kilograms of coal. Each refueling outage, we replace 1/3 of the fuel, which means that each fuel assembly lasts approximately 4.5 to 5 years in the reactor. Once placed in our reactor and introduced to a radioactive source, the fission process begins. This is where the nucleus inside the millions of tiny atoms inside our uranium pellets split apart. One of the byproducts of our fission process is heat, and it's this heat that we use to heat our water. The fission process is carefully controlled inside the reactor. The water in the circuit passes around the reactor, picking up this heat, heating the water to the required temperature. During a refueling outage, the used or spent fuel is moved to our fuel pond for long-term storage. After a number of years, it is moved to our dry fuel storage facility. Fuel from Sizewell B never leaves the site and is permanently, safely and securely stored here. One of the other byproducts of the fission process is radiation. It is our responsibility at Sizewell B to safely manage the radiation. Our first priority is to minimise the amount of radiation produced during the generation process and ensure that any radiation remains inside our radiologically controlled area. Our radiologically controlled area, the RCA, is a relatively small area of the power station. Access and activities within this area is tightly controlled. We manage any radiological waste by firstly cleaning any equipment used to reduce the radiological impact. Equipment and items that cannot be cleaned are packaged into specialist drums and sent to a low-level waste repository for further cleaning and long-term storage. The world-class design of Sizewell B puts reliability and safety at its forefront. We also have many backup and safety features. Sizewell B uses approximately 60 megawatts of the energy it produces to power the station and all the associated essential safety systems. When the station is not generating electricity, this power comes from the national grid, just the same as any home or business. A further backup system at Sizewell B is the Reserve Ultimate Heatsink building. This is a backup to our cooling water system and can be used as a way of removing heat from safety-related systems on the station. The building uses airflow through 32 large fans to cool heat exchangers. We use a lot of water here at Sizewell B. We have 3 water circuits. The first one passes through the reactor in a closed circuit. The second one is also a closed loop and passes through our steam generator. Finally, we have a cooling water circuit, which is an open circuit to the North Sea. In fact, we use 3 million litres of the North Sea per minute. The seawater warms slightly as it travels through the condensers before it is sent back out to sea. The temperature increase in the water that we send back out to sea is only about 3 to 4 degrees warmer than the water that we bring in. This doesn't have an impact on the marine ecology, and we use independent marine scientists to continuously monitor the ecosystem offshore. To ensure only water enters our cooling system, we have introduced a fish return system. We have 4 drum screens which filter out fish and other marine wildlife. There are 4 drum screens and 4 cooling water pumps. This level of backup ensures that we always have the equipment we need to safely operate. The turbine hall is where we use the steam that we produced in our reactor building to generate electricity. This is our second closed loop, our steam loop. The steam from our steam generators is sent to the turbine hall, where we have 2 identical turbines, each using 1 tonne of steam per second to generate 630 megawatts of electricity each. The steam first passes through the high-pressure cylinder. As the steam reaches the cylinder, it expands, pushing the turbine blades, turning the blades attached to a centre rotor shaft.